Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night, the Wednesday Experimenters Group Night, and Justin VK7 Tango Whiskey at the microphone at the desk in the studio. And if you're coming in through streaming, please let us know that you're coming in and where you're coming in from. And hello to Peter. Peter in Victoria and David DBX, Bronson the Cat and Andrew Elwell and Muggins forgot it was Wednesday till late. Okay, that's all right. You can watch it in the comfort of your home. Now we've got many and varied subjects tonight. When I a couple of days ago I thought, I'm not sure that I've got too much to do here. And Ross VKK, thank you. Hello. And I sat down to write the running sheet, and ended up with having to leave stuff off the running sheet because there was a fair bit of it. The very very first thing that I want to show you is a recent tip shop find. So. When I went to my local resource tip shop, and this rather scungy looking box was sitting on the shelf. Aurora Energy, which is our local energy retailer, Rosalie, which is up in Launceston, and it said the ground service in the north, and MicroOhm Meter from CHK Engineering. So I opened it up to find a CHK Engineering MicroOhm meter. Surprise, surprise! So it was what was in the box. I don't know whether it works or not. There was a do not use sticker on it. So you have to be a little bit careful there. But so. What this is used by line trucks, substation safety instrumentation people to check the ground resistance between 2 points. And it is basically an ohm meter, but an ohm meter that enables you to go, and it's what we call a 4-wire ohm meter. So a 4-wire, and I'll explain what that is in a sec. but a 4-wire ohm meter that goes all the way down to MicroOhms. So it measures, and you can see there's a bit of a scale here. There is 20 ohms, which is currently on, 0.1 of an amp, 2 ohms, 0.1 of an amp, 200 milliohms at 10 with 10 amps, and 20 milliohms at 10 amps. So this is the scale that it measures in. When I picked it up, it was actually quite heavy, and I went, oh, okay, there's something in this box that's pretty damn heavy. And when I looked at this scale, I thought, oh, okay, this box is capable of supplying 10 amps of current to enable it to measure the resistance. So I ended up finding out that the weight was the gate cells, and I'll show those shortly. I'll show those in a minute. But there were 4 2-volt 12 amp gate cells in rechargeable lead acid batteries behind this. They were all absolutely dead flat. I've managed to recover 3 of them, but the 4th one's not playing ball for me. So anyway, I did a little bit of rewiring because there is an external supply as well as a battery supply arrangement in here, and I've just put on there no internal battery in there right at the moment, and I supply 8 volts DC at 10 amps. Now if I just zoom down a little bit here, you will see that sitting under it is a power supply. There's a power supply, and if I zoom in here, zoom out, zoom in. If I zoom in here and then do a bit of a focus, you'll see 8 volts, and it can supply up to 15 amps is what I've set it to. It sits there at about 0.2 of an amp. So that's good. Let's zoom back out again, and we'll go back up again. And it does draw 10 amps from that power supply when it goes into those lower scales. So, what can we do with it? I'm glad you asked. The 4-wire, the 4-wire arrangement measurement technique is a technique for measuring very low resistances. And what they do is you've got your measurement terminals, which are these C1 and C2 here. So it could be that this is one earth stake and this is another earth stake, and you want to actually measure the earth resistance between those 2 earth stakes. There are sense terminals here. So there are 4 wires. This is why it's called a 4-wire technique. This is, and you'll see, I've just temporarily wired this up so that this bit of desoldering braid, which is reasonably low resistance, goes between C2, goes to P2, there's a loop just here, and then it goes to P2 and back to C2. So the 4-wire method, one pair injects the current, which is the C1 and C2, which is these 2 here, up to 10 amps, injects the current through that circuit, through the earth or whatever you're measuring through. And then the sense leads, which is this P1 and P2, this is actually where you're sensing the voltage drop, if you like, across the resistance. And so this is, and the reason you separate these is so that this is not influenced by any of the current that is being injected in here. So, and because there's no current that flows through these sense leads, what the device is measuring is the voltage that's developed across that particular resistance that you're measuring. So that's the 4-wire sense arrangement, and it's the common arrangement that you use for resistances down to microohms and milliohms. So we've got it on. There's an auto range or there's a manual range. Forward and reverse, so you can reverse the polarity. And then there is an alternate, so it alternates between the 2 of them, and I'll demonstrate that in a minute. What we'll do, we'll leave it on auto, we'll press the measure button, and you'll notice that very quickly went down to 200 milliohms at 10 amps, and it's measuring 18.1. So it's 18.4. It's just temperature. This is going up. That's getting quite warm because there's 10 amps flowing through it. 17 point, and it went down when I touched it. So about 17 milliohms that it's measuring between these terminals here, and it's gone down to the 200 milliohm range. So if we stop that and we go to manual, we can go down even further here and we measure. So we start up here and you'll see the scale 0.016. Let's go down 0.0164, go down to the 200 milliohm, 16 point something, and then we can go down, because it's below 20, we can even use this, and it's 17.8, 18 milliohms, and down to 3 decimal points. So, and it is drawing, I won't put the camera down, but the power supply is telling me it's 8 volts at 10.12 amps that it is actually drawing. So it is, and this wire is getting quite warm because it's got 10 amps going through it, which is why this is varying, because it's as the temperature goes up, the resistance will change. So we'll stop that. So it's a milli or MicroOhm meter, goes down to milliohms, ohms, milliohms, and then with these decimal points you can go all the way, measure all the way down to microohms. So interesting bit of kit, and will certainly be employed. Will certainly be employed in the 7TW shack. Occasionally I have to measure earthing arrangements. I did that the last time I did that in earnest. I was for the 630 meter arrangement that I had. Oh, okay. Now who we've got? We've got VK4KEN Ken. Hello, Craig Westlake. Evening. And Craig's new call sign is VK7GIN, Golf India November. Gin, I love it. I do like gin as well, so there you go. Like whiskey better, but hey, beggars can't be choosers. Now, these, I mentioned the batteries. These batteries, I'll put them over here. These batteries are reasonably large. In my hand next to them, these are 2 volt 12 amp hour Gates cells, so they're lead acid batteries, but they're a solid electrolyte. They don't leak. You can use them in any orientation. They don't leak, they don't gas. Very nice cells, very expensive cells if you want to buy them. But that gives you your 2 volts at 12 amp hour, literally. And as I said, I've got 2 of them. Three of them are starting to come back, starting to take a charge and maintain a charge. But that fourth one is taking its time. Oh, okay. And Darren, hello Darren, and hello Andy. Welcome to tonight, and welcome back to the Wednesday evening experimenters group. So MicroOhm meter, really handy piece of kit. It cost me about $28 at the resource tip shop, for those who were wondering. You never know whether it works or not. They certainly don't test them at the resource tip shop, because I suspect they don't know what they're looking at. But it works a treat, and will certainly be used in the 7TW shack. So worth a look at your local resource tip shop. You never know what you're going to find. Now, okay, let's go to the Technical Advisory Committee of the WIA. Put out a advisory paper, a consultation paper. Let me go back to the beginning, and if we do a transition here, okay. It's called the IARU Region 3, so that's where Australia is. We're in the International Amateur Radio Union Region 3. It's the HF Band Plan Committee is putting out a paper around potentially harmonising and the harmonisation challenges involved with the 40 metre band. Now, the 40 metre band, okay, give you a bit of background. The International Amateur Radio Union is the only amateur radio body that is acknowledged by the International Telecommunications Union. So that's the amateur radio body that the ITU listens to. We have three regions, Region 1, Region 2 and Region 3. We're in Region 3, which includes Oceania and a whole lot more. Now, 40 metres, I'll just zoom down a little bit here. I just want to go to this picture here. Now, this picture shows you why we need to consider doing this. So this is the 40 metre band plan comparison across each of the regions. The very first row is Region 1, the second row is Region 2. There is one for the USA because it's quite different in the USA. And then there is Region 3, which is where we are. And then there are a range of other countries which are included in there as well, which have different band plans on their 40 metre band. And across the top is the frequency, so all the way from 7.0 to 7.2 in this particular case. Now you'll notice the blue is CW, the red is data, the green is voice, the yellow is and labelled up yellow is WSJT mode. And then there is also a special use, which is in the Japan band plan. So you'll notice that there are some regions which are aligned. Region 1 and Region 2 appear to be aligned, although the USA, if you look at data, which is the red section, is much larger than any of the others in Region 1 and in its Region 2. Region 3, our data segment is a lot bigger, and then the variations to Japan, to Indonesia, to South Korea. South Korea has a really, really small data section. Most of it is voice. Malaysia, pretty close. Australia is different again. So what this paper does is lay out what the issues are, what the differences are, what we're trying to do. Now, this is can I just stress, this is absolutely the start. This is the start of a very long journey to try and get some global harmonisation. And 40 metres has always been problematic, but this is at least making a start on putting a position to the Region 3 IARU meeting, which is in November. Unfortunately, on the same weekend as our HamECon, but I won't go there. And once we get some degree of consensus in our region, we then go to the IARU meeting, the main meeting of all regions, and try and get some sort of consensus at that sort of meeting. Now, there is, it's not that is not an easy thing to do, and hasn't been in the past. So it is a lot of work. It is a lot of convincing, a lot of hallway meetings, a lot of discussions outside of official meetings, and all sorts of things to try and get some sort of alignment and harmonisation. So it's worth a look to, and I'll put a link in the video description to this particular paper. You please have a read if you're interested in what goes on the 40 metre band and what you can and can't do on the 40 metre band. Please have a look. If you've got some comments about particular things, then please make the comment, and I'll give you an email address in a sec. the main issues which this diagram highlights: inconsistency across regions, specific national regulatory conditions and constraints, and the key one that stands out on this particular diagram is the USA. The USA has a huge segment. This is FCC regulations. There is a legacy band allocation that haven't been resolved and revised since the band expansion at WARC 2003, prior to which the 40 metre band was only 100 kilohertz wide, so it was 7 to 7.1, and then we got 1 to 2, 0.1 to 0.2. So there are a whole lot of things that we need to work through, but please have a look at the paper. I'll put the link in the video description. The feedback needs to be to the TAC by the 6th of September. I think it's September. I wrote down December here, but it's the 6th of September. And the TAC email address is tac@wia.org.au, and I'll put that in the video description as well. But please have a look at it. The TAC have done some analysis of club log about what the usage is between modes. They've made some not recommendations. They've made some suggestions and are looking for feedback on those suggestions and proposals. So please have a look. If you're interested and if you've got some comments, please email them through to the TAC. So please make the comments you need to make. Now, hang on, let me go back to, let me see, who else has been years since I've had to use a doctor like that. Okay. Well, this device ended up in the correct hands. It did. You're right, Bronson. Not a problem at all. It did. Oh, that's if they watch our YouTube channel, David, and I doubt they do. But you never know your luck in a small city. Now I've got, and this will appeal to appeal to Peter, I think. And Peter, please chime in here if my facts are not quite right. But I thought I'd do a little bit of a terminology, a Morse code terminology, a Morse code instrument terminology. That's a better way of putting it. Because if you look up what's the difference between a bug and a Cootie and a semi-automatic and an Iambic keying arrangement and a keyer, and there's lots of folklore out there, and I thought I would try and go through and give you an idea with a demonstration of each of the different types of keys and what they're called. So the first one I was going to start with. Oh, that's handy, isn't it? They're starting to talk to me. Now, the first one I'm going to outline, which everybody knows, is a straight key. Now, Peter will recognise what this straight key, I hope, and I'll put it on the. This is. Let me go. Yeah, there we go. Now, this is a Marconi. Let me just. There we go. A Marconi. So the Marconi Instrument Manufacturing Company, MIMC, Chelmsford, England. This is a Marconi marine key. This came off a ship. And it is off the... Oh, very good, Bob. This is from Bob Reed, VK7RD. The key is the XMB Goliath. So this is now the Goliath was a freighter, I think, from memory. I think it was. But the MV Goliath is where this particular key came from. They are beautiful keys. They are absolutely beautiful keys. Let me zoom out. That's the key. And if I turn it sideways, you'll see these are roller bearings for the arm that goes through and it pivots on. These are roller bearings on both sides. It is a beautiful feeling key for a straight key. Very typical. The terminal block. There are on the bigger Marconi keys. There are a couple of inductors, tapped inductors on those bigger keys. I've got one of those. But this is a Marconi Marine, what we call straight key. So this is a straight key, as in it is on off, and you control, the operator controls the dits and the dars. So and they have full control of the dits and dars. So the full control of the dits and dars, you can hear. So they have full control. Now that's important. Remember that fact. Full control of the dits and the dars. Now the next key, which I don't have an example of, I didn't bring one with me, but the next one is what they decided, what they started to experience was a thing called glass arm. And a glass arm is effectively RSI in the telegraphy industry, where operators were getting RSI because of the straight key action. So what they decided to do was turn it over, so it was a Sideswiper or a Cootie, and they found that the sideways movement didn't cause as much glass arm than the up and down movement. So they created basically turned the straight key on its side, put a paddle on here, and it was still the operator's responsibility for the dits and dars. So, but it was a sideways movement which caused less problems. So that's a Cootie or a Sideswiper key. And I do have an example of that at home, but I didn't bring it with me, so I apologise for that. The next one that we look at is, and I've got a couple of examples of this. This is a high mound single, or a bug, what they call a bug or a semi-automatic key. Now I'll take the top off and we'll have a close look at the mechanism in here. I'll turn it around, and okay. So this is a high mound. Oh, and let me just. Okay, that's a bit better, a little bit better. Now this is a single paddle. Single paddle goes sideways, goes one way and the other way. So let me just, and I'll connect this up to the keyer I have here. Now the interesting thing about this is connected exactly the same. There are two connections here, very similar to a straight key. And if I connect it up to the tone generator, you'll see if I push this way, I can create the dars. And if I push in the other direction, you'll notice there's a little counterweight here and a little spring. It's on a little spring just here. And it bounces and creates the dits. And I'm not a bug operator, so you'd have to get used to how much. And these are all adjustable, so you can adjust that amount of bounce by moving this counterweight forward and back. But the key thing with this, oh, that's a bad pun, isn't it? The key thing with this is that it is the operator who is creating the dars, and the dits are semi-automatic. And the semi-automatic nature, so it's called a bug or a semi-automatic key. Now, there's a couple of examples that I've got of those, and this one, I absolutely, this is one of my prize collections. And Peter said something here. I have one of those, Ex-Aurora River A&L. So is that the straight key? The straight key that we're talking about there, Peter? I assume it is the Marconi key. Oh, hang on. We've got a. Oh, I know what it is. It's the shorting bar. The shorting bar on the side. Now, this particular one. This is an Eddystone. This is an actual Eddystone key, and it's a bug or a semi-automatic. Uses and goes in the same, uses the same sort of mechanism. And if I take the top off, and it's very it's in that wonderful HamECon. And David, yes, you can slow the dits down by moving the counterweights. So you move them out or you move them in. You move them out to slow them down. You move them in to make them quicker. So this is also a bug and a semi-automatic key. In one direction. So in this direction, we create the dars, and in the other direction, it's creating the dits. And this is set up, this has actually got two counterweights on it. And if you want to really slow it down, you move all of these, and I'll demonstrate. That's about there. If we move this, we put a bit more weight right on the end. Oh, turn it around. Let's move, can I move this a little bit further? Oh, we're right at the end here. Move that back. I think I've gone in the wrong direction. That's even faster. You get more dits though. You get more dits at the same speed. No, I'm right on the end there. Let me go all the way down here. This is all about bug tuning, which I admit I'm not an expert at. Oh, that has slowed it down. That has certainly slowed it down. So oh. That's a very disjointed call sign. I really mashed that, Peter. But so this is a bug. This is a bug or a semi-automatic, and the semi-automatic side of it is the dits. So the counterweight gives you the dits. So, and this is, in this particular case, this is a very nice Eddystone that I will be adding to my collection. I do actually have an Eddystone key, but I never got the cover. I never got the cover, and so I now have one. I actually have a cover for it. So that's a semi-automatic, a bug or a semi-automatic key. Now we go to, here we go. This will test me. Now we go to what is called a single lever. And this is a single lever Vibraplex Deluxe, courtesy of Larry, VK7WLH, who very nicely sold me this particular key. So this is a single lever paddle. So it's one lever that goes all the way through. You can hear there is dits if I push this way, and dars which I push this way. And if I keep my finger on there, it just repeats the dars on one side and the dits on the other. And I can slow it down or I can speed it up. And I'll go into the keyer in a minute. So this is now, Peter, the other semi that is highly now, Peter, I have an Australian Simplex Auto in my collection, which people keep wanting to buy off me. So there you go. And I know I should have bought the Australian Simplex Auto along. It is an Australian semi-automatic key that was fully produced in Australia for quite a while, and they're highly prized because there's not that many of them still around. So this is what we call a single pedal. Now the key thing here, another pun, the key thing here is it is not the operator who is creating the dits and the dars. It is a keyer, an electronic keyer, either in the transceiver or it's a separate box, which I'll show you in a sec. What the operator is doing is basically selecting the number of dots and dars through sideways movement to the dars. I'm right on the dars. Yeah, and so it is the keyer that's creating the dits and the dars. It is the operator who is controlling the keyer of the dits and dars. So that's a single lever paddle, a Vibraplex paddle, and that's a Vibraplex Deluxe. So now we then go to a dual pedal. So a dual pedal keyer, dual lever paddle. Now let me just plug this one in. Oh, hang on, what's going on here? There's no plug cover on this one, so I've got a little bit of shorting going on. Now, very similar. There are two levers with two switches, two separate switches, same as this one, but this is a single lever, and one side pushes one set of contacts, and this side pushes the other set of contacts. In this particular case, there are two sets of contacts, but they are connected via one pedal or the other pedal. So dots and dars, exactly the same thing. It's going through an electronic keyer, and it is the operator who is controlling the number of dits and the number of dars. So, and this is a WM9, I think they're New York, I think, from memory. Hang on, let me look at the bottom. No, Bellevue, Washington. Bellevue, Washington, made in the USA. So, so this is and quite large pedals, very heavy bass, very much like the Vibraplex. That is all steel at the bottom. A very heavy device, doesn't move around on the desk. But again, dual levers. This is a single lever. That's dual lever, and you need a keyer either in the transmitter or in or a separate keyer to actually use these keys. Now the keyer. Now this particular keyer that I'm using to demonstrate this is a oh, hang on, I just zoomed off the screen. This particular keyer I built. It is a design that it came out of the IARU handbook, I think, from memory. It is a couple of CMOS ICs. You've got a couple of, you've got speed, you've got volume, there's a LED. There is, now, I've put a USB sound card in here. So there is a USB connector that plugs out the back of here that I can plug straight into the computer and get sound, USB sound out of here. The on button, USB or speaker, so I can switch between the two of them. There's a speaker in the top. There's a whole lot of, there's the transmitter, so a connection off to the transmitter, because there is a relay in here. So as you hear the dots, it's actually keying the relay as well, which keys the transmitter. And there is the pedal connection. There is the USB sound card in here and a power connection. So this is an electronic keyer. You can see if the speed, if you're into high-speed Morse, I'm not. So that's the keyer that you use with the with those, either a single or a dual pedal. So we've been through straight keys, we've been through Cooties or Sideswipers, going sideways, a bug or a semi-automatic key, so there's the little counterweight on it that creates your dits, and you've got full control over that, mechanically control over that, and it is the operator that creates the dits and the dars and the length of the dits and the dars. We've got a single lever pedal, so the Vibraplex single lever pedal. It is the keyer that creates the dits and the dars. There is a dual pedal, again, that need a keyer to do the dits and the dars. And you might hear, when you start Googling all of this and going down this rabbit hole, you might hear, is it Iambic A or is it Iambic B? Well, what that means, and a lot of transceivers that have built-in keyers enable you to set Iambic A, Iambic B in keyer mode. You can set the speed, you can set all sorts of things, but you can set whether it's Iambic A or Iambic B. What that means is, if you have two pedals, what does it do, what does the keyer do when you push both of them together? Now, Iambic A, the keyer will finish the current element and then stop. Now, my keyer is not Iambic A or Iambic B. It's not that at all. It'll keep going with dars. So that's if you've got the ability to set an Iambic A or Iambic B, then the Iambic A, when you push them both together, will finish that current element and stop transmitting. Iambic B will finish the current element, send one more element, so one more of the same element as what was just sent, and then stop. So Iambic A and Iambic B, if you've been, and this is all about your training, if you're trained in Iambic A and Iambic B, you expect it to stop after when you push those two paddles together. If you haven't been trained in Iambic A or Iambic B, don't worry about it. So what are your thoughts on people using computer programs and keyboards for CW? Well, David, certainly using keyboards for sending CW, don't have a problem with that. If you're using it to decode, then why are you even using CW? I think it's useless to decode. That's my own personal opinion. I think it's useless to decode CW. But once you've mastered the head copy and the head sending, then by all means, and a lot of people use computers to send CW, especially in contests. You'll see them at the keyboard, but what they are doing is they are listening to the CW and they are decoding in their head the CW and then responding on the keyboard. That's great. Don't have a problem with that at all. But if you're using it to decode your CW, then yeah, I think that sort of defeats the purpose. So not when you, oh, okay. What happens when you squeeze the two pedals together? It is, okay. Lance has just chimed in here. Iambic A and B is what happens when you release the pedals, not when you push the pedals together. So when you release both pedals. Yeah, okay. I'll take that on. I'll take that on notice. Thank you, Lance. And Richard. So this is Peter Young. CW is an art. It definitely is. That once mastered gives greater satisfaction. Well and truly. And I'm in the head copy space right at the moment. I learnt writing everything down, and I am trying to get my mind out of that mode. So I'm trying to head copy. So yeah, and Lance, I will certainly look that up. It may be when you release, not when you push them together. I thought it was when you push them together, and the keyer, depending on which mode you were in, would stop at a particular point. But I may be incorrect there. I will put in the show notes, in the video notes, the reference that I used for this information. It's a great read if you want to dive into this rabbit hole. So, straight keys, Cootie sideswipers, Bug semi-automatics, single lever pedals, dual lever pedals, keyers, and Iambic A and B. So if that hasn't given you enough to go off and and look up more, my job is not here. Is not finished. My job is not finished. So. I hope you found that vaguely interesting with some demonstrations. Now, HamECon. Have we got a deal for you? Let me go here. Now, we have a few more sponsors and raffle prizes that I can announce. So, we currently have as event sponsors ICOM and their 60th. It is their 60th anniversary. They will be bringing equipment with them. Some impressive equipment to show off, which is showcasing their 60 years. TET Mtron Mark VK6 MOA has very generously donated some raffle prizes and is a supporter and sponsor of the event. Dennis K0TX from DigiRig is supplying some very nice vouchers for DigiRig interfaces for them. Callum M0 MCX from DX Commander has donated a very nice antenna which will be part of the raffle prizes. Fantastic, and thank you, Callum. And Harry from Zactech SM7PNV. Now he produces a whole range of things, but what he's supplying us for the raffle prizes are a number of whisper transmitters, self-contained whisper transmitters, which he's certainly known for. So absolutely fantastic. And of course, Ham Radio DX Hayden is also supplying, and hosting and supplying raffle prizes will be Reast. We're looking at raffle prizes. There's probably going to be a 7300 up for grabs. There will be an FTM 800 from Yaesu up for grabs, and there will probably be an ID51 handheld from ICOM as well. So our raffle prizes are increasing. Our sponsorship is exploding. And also, if you're wanting to become a sponsor, please email us at tassiehamconference@gmail.com. And if you have not, booked yet, please have a look at the Ham Radio Conference website, HamECon, Tassie HamECon, and there is the booking QR code. And you can book. This year's event is fully catered, so we took on board the feedback from the last one, and this is fully catered, so you will not have to worry about food throughout the Saturday and the Sunday. Please book. There's lots of bookings have been coming through, and we're certainly being flooded with raffle prizes and sponsorships right at the moment. So watch this space, and I'll be outlining raffle prizes and sponsorships over the next couple of weeks. As well as there are a couple of presentation slots which we're working on right at the moment in filling with some very interesting presentations. So watch this space. Now, as we normally do, space weather report. We've had multiple CMEs hit us. In fact, there was some auroral activity last night. I saw some interesting pictures that were posted on various sites for last night. So there was some auroral activity. There is a geomagnetic warning out for the last 3 days. G2's slight chance of a G3. I'm not sure we quite got there, but anyway, that's up to the 31st. So sequence of CMEs have arrived. There is a HF fade out warning. So on the 31st, R1 to R3 probable. If comms difficult experienced, try higher up in frequencies. There is also a current fade out warning. Actually, they've removed that. There's no event anymore. And there is a HF comms warning out right at the moment, last updated today, and degraded HF propagation conditions expected from the 31st to the 1st of August. If comms difficulties experienced, try a lower frequency band. A more detailed HF warning will follow if depression eventuates. So this is telling you to go down, and the other one's telling you to go up. So don't you love warnings? And there is a good reason for that. So that's your space weather report for today. Now next week is a fantastic event. We have it's the first Wednesday of the month. We have Mike VK7FB, Mike Jenner, who was in the lighthouse service. Served in 4 of the Tasmanian lighthouses and is giving us a talk on his experience in words, pictures and videos. So that will be up here in the domain, and I'd probably get here early because there's a lot of people saying that they're going to be here, and it'll be standing room only, or watch it via the stream. We will be streaming it. There is the second Wednesday night, so that's the 14th of August, is our DX forum. So if you're out chasing DX, then please come along to the forum. Let us know how you've been chasing your DX contacts, whether you've got your DXCC or you're working towards it, and what your secrets and trade if you're prepared to share your trade secrets, and how you're extending your distance through antennas and power and all sorts of stuff. Then the first Wednesday night, September the 4th. Now, we won't be up here. We will be down at the Channel Men's Shed. The Channel Men's Shed is hosting Reast and giving us a guided tour of the Men's Shed down at Margate, 24 Van Morey Road at Margate. There will be a sausage sizzle down there as well, $2 a snag. So we'll get a guided tour and a feed down at the Channel Men's Shed. And then and this was purposely chosen for this particular date, on September the 11th, we will have a forum on the zombie apocalypse, or what do you do in an emergency communication sense when the space weather event is such that it has taken out all of the communication satellites, all of the FPOS, all of the internet, and you're left with your amateur radio station being the only thing that's still operating. So how to survive the zombie apocalypse on September the 11th. VK4YT, Yeti Radio, hello. Looking forward to HamECon, definitely, and the prizes on offer. Yes, they're becoming a pretty impressive list of prizes on offer. So, and the only way that you can get a raffle ticket is if you are coming to the conference, you get a complimentary raffle ticket, and you can buy raffle tickets at the conference on the Saturday and the Sunday. So, but the only way you can do that is if you're here. So yeah, you've got to be in it to win it. So good stuff. Okay, that's how we going for time. 25 past 8. Love it. All right. This has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Reast with our DATV Experimenters Night. And this is VK7 TW signing off 73, and we'll catch you in 3 weeks' time. So the presentation night and the forum night, and there you go. Now, we don't... Oh, very good, Lance. We don't need a Carrington event to wipe out modern technology, just a Windows update. A couple of Fridays ago, we just need a Windows update. I love it. On that note, 73, have a fantastic week, and we'll catch you in 3 weeks' time. Cheers.